All right, so since the nuclear reactions deal with stuff in the nucleus, so let's review atomic symbols, or like the symbol that we to represent what's inside the nucleus. Okay, so first of all, we have atomic number, which is represent the number of protons, and also the number of the electron in the neutral atom. Right, so the neutral atom, the number of proton and neutron are the same. Okay, so we have atomic mass, which is the number of protons and neutron combined. Okay, if you still remember that the mass of an atom are the 99.99% of the mass of an atom come from the nucleus, right? So it's small but dense in mass, and electron is light, so we'll say that the electron doesn't have a mass. Okay, so we have mass in grams, and electron is about 1,000 times less lighter than neutron and proton. Neutron and proton are really close in mass. Neutron is a little bit heavier. We also have the mass in atomic mass unit, or AMU, or just U, or just Dalton. Okay, those are the same atomic mass unit. So the neutron and proton are about 1, electron is 0, approximately. Okay, and okay, we have the one word, so nucleon. Nucleon represent the definition. By definition, nucleon means subatomic particle in nucleus, which is only protons and neutrons. If I say nucleons, it means, okay, look at proton and neutron, no electron in here. Okay, and mass number, so number of nucleon. Mass number basically is the number of nucleons, right? So mass number here has nothing to do with electron. We also have the word isotope, right? The term isotope, which is the same element, so same proton, same element, but different number of neutron, right? For example, so bromine on the left side, so 35 proton, also 35 electron because it's neutral. The neutron is 79 minus 35, the rest is going to be neutron, which is 44. Bromine 81, you can see that there are 2 neutrons higher than the bromine 79, so same proton, same element, same proton. Number of electron also 35 because this guy is neutral, right? And neutron 81 minus 35, you get 46. Okay, so isotope is basically same element, same proton, but different in neutron. Okay, so right there, same element. Another common isotope, so we have proton, deuterium, tritium. All of them are hydrogen, so the number of proton is going to be 1, right? If you remember, change number of proton, you change the element, okay? The only difference is the number of electron, the number of neutrons. So we have 1 neutron, 2 neutrons in tritium. Carbon, we have carbon 12, carbon 13, carbon 14. All of them have 6 proton, but the difference, only difference is the number of the neutron. 6 neutrons, 7 neutrons, and 8 neutrons. Okay. All right. So indicate whether or not each of these nuclei is an isotope of carbon 12. Right. So let's take a look at carbon 12 first. What are nucleons in carbon 12? If you look at the periodic table, so 6 proton, 6 neutron. That's carbon. Okay. So basically, the isotope of carbon is gonna be carbon, so 6 proton, right? Can be 5, can be 4, can be 7, can be 8 proton. Because carbon is 6 proton, right? But the difference can be the difference in neutron, so different in mass, basically. All right, let's take a look. So in A, a nuclide with atomic number of 5. Atomic number of 5, what does this tell you? That's the number of proton, 5 proton. This is totally different element from carbon, so that's not isotope, right? The definition of isotope is the same proton, right? Different in neutron. Okay, same proton, same element. So this is 5. 5 is was it carbon group 4, group 3, boron. This is boron, and mass number of 12. So I'm gonna just use A, element A. Okay, so there are 6 neutron. Sorry, 5 proton. So this is not carbon, not isotope of carbon. Okay. Next one, a nuclide in which 6 of the 13 nucleons are positively charged. All right, 13 nucleons. That means these are subatomic particles in the nucleus, which is a proton and neutron combined. 6 of them, 6 out of 13, are positively charged. So 6 of them are proton. Yes, this is carbon. All right. So 6 carbon, 7 neutron. That's carbon 13. Okay. I just say that. I just call them let's say element B. So 6, the atomic number of 6 protons, same element. Okay, so this is new isotope of carbon 12. Now C, A nuclide with 8 proton, but that's oxygen, 8 proton. Yeah, I just use element C. Okay, so 8 protons, totally different element from carbon 6. So that's not isotope of carbon 6, carbon 12. And the last one, a nuclide with 6 proton, 6 neutron. Of course, 6 proton. Oh, 6 proton, that's also carbon. This is carbon 14. We got carbon 13 and carbon 12. Okay. All right, let's talk about nuclear symbols.